The Mars Reconnaissance Orbiter has been orbiting Mars for 10 years already. On board the spacecraft is a very special scientific instrument called the HiRISE camera. It turns the spaceship into a scanner, imaging the surface of Mars in incredible high definition and detail. The camera it uses is not like a conventional camera, which captures everything in a set frame. Instead, it's like a photocopier that scans an image line by line. This is especially convenient for an orbiter, as it is moving around the planet anyway. HiRISE has taken some of the most stunning images of another celestial object I have ever seen. Wanted to do a bit of a different video, investigating HiRISE's true color images while explaining what it is you are looking at. Today's video will focus on the polar regions of Mars. I'm using Google Earth so you can see where each image was taken. Google Earth, surprisingly, also has the Moon and Mars included. The first image is found near the North Pole, near a group of sand dunes. These dunes are the closest thing to snow you're gonna see on Mars. This is actually a frost made of carbon dioxide. You see, most of Mars's atmosphere consists of carbon dioxide. And because Mars can get much colder than Earth, and with a much lower air pressure, it means during the winter on Mars, some of this atmosphere condenses onto the surface. It's very similar to how water vapor freezes as frost on a cold night on Earth. However, the frost on Mars is seasonal, and when spring comes around, the CO2 will sublime back into the atmosphere. This is the process of a solid turning straight back into a gas. The next image is found in a crater near the South Pole. Craters near the poles tend to be a bit more protected against the sunlight than flatter surfaces, which means the frost lasts a bit longer into the spring than normal. You can still see the frost in this image, although you will notice these dark blocks too. These are called seasonal halos, as they appear in the spring. What is happening here is sunlight passes through the couple of meters thick ice sheet, heating the dusty surface beneath. The ice near the surface sublimates, creating an air pocket of increasingly pressurized carbon dioxide. Soon cracks form in the ice sheet, releasing the carbon dioxide as gas jets into the atmosphere. These jets also kick up a lot of dust hundreds of meters into the air, which is what causes these dark deposits all over. These jets are thought to look something like this, and must be quite the spectacle up close. Researchers theorize that the ground would rumble while standing on these thick, dry ice sheets while the jets go off all around you. What I really find interesting about this image is some of the deposits have veins coming from them. That is thought to be the finest and lightest dust pulled out from under the ice by the sudden release of gas once the cracks form. This leads us nicely onto our next image, which again is found near the South Pole. I'm using a height elevation map this time so you can see how this next image is right in the middle of a big sand dune. In this image you can clearly see that there's a prevailing wind as these gas jets were going off. This is why all the dark deposits are in fan shapes. Further across the image, however, you can see the jets on this side of the dune were going off at a different time, so there was a different prevailing wind direction. The shape of the dune could have also impacted the wind direction for this other side. The dark spots are between 20 to 100 meters wide. In this image, we are in the southern hemisphere again, but this time a little higher north. Because we are further away from the pole, there is not as much of a permanent frost throughout the year. When the ice is present, it looks very thick, even appear in blue at some points. Contrast that to the same crater, but about 2 Earth years later, and you can see the sand dunes that were hidden under the ice. With both images overlapping each other, you can really see what seasonal variations do to the surface of Mars. And what video about the polar regions of Mars would be complete without a look at the polar ice caps? These permanent features are here for the whole Martian year and are extremely thick, a few kilometers thick in some places. These patterns form with sublimation of dry ice during the polar summer. Under the dry ice is much more stable water ice, which does not melt all year long.